Welcome to this video. Here we are going to perform basic static analysis on the malware executable. But first, let me run you through the main contents of the video. First, we'll be running the malware through VirusTotal scanner, as it is always a good practice to scan the malicious executable to identify if the malware has been discovered before. If so, this will give us an idea about the functionalities of the malware. From there, we can take note of important artifacts to look out for during our analysis. Next, we will be doing deobfuscation and unpacking of the malware. One way to obfuscate a malware is by packing it. This is a very important step because we won't be able to analyze strings or view imported libraries of the malware if it is packed. Then we will proceed to malware fingerprinting to create a hash value that is unique and cannot be reversed. This will help us identify the malware, and if any file found with the same hash, it will be a clear indicator that it is the same file. After that, we will extract administrative information about the malware just to gather some basic information, probably the date it was created. Next, we will try to look at the imported libraries and functions of the malware. This will help us determine what the malware is trying to do, as all applications rely on imported functions to work. We will then perform a string analysis on malware to extract host-based and network-based indicators, which may help identify the functionalities of the malware further. We can also use this discovered string to help us with our dynamic analysis, so we know what to look out for. Lastly, we will summarize our findings at the end of the analysis, just to recap on what we have found. Now I just want to run through the tools we'll be using for this analysis. For VirusTotal scanning, we will need to visit the website virustotal.com and get the hash of the malware and see the results from there. For deobfuscation and unpacking, the tools we are going to use to examine if the malware is packed will be PID, RDG Packer Detector. As for unpacking of the malware, we are going to use Faster Universal Unpacker, or FUU. Now moving on to malware fingerprinting, we'll be using WinMD5 to generate a checksum value of the malware. For administrative information, we're going to use PEView. This will help us determine time date stamp of the malware and examine some of its PE sections. For analysis of imported libraries, we will be using Dependency Walker and PE Studio. Dependency Walker let us view its imported libraries and API functions. As for PE Studio, this will scan the portable executable and help us spot suspicious artifacts, be it a string or an API call. Finally, for string analysis, we are going to use bintext. Moving on to basic static analysis, we have here the malware zip file. So we're going to copy that hash and open up virustotal.com and just key it in there so it'll run through. And as we can see that there is 70 antiviruses and 60 of them have detected that the malware is a bagel. As we can see, it's a worm, email, Win32 bagel. So bagel is actually a mass mailing worm. So looking at the Wikipedia, we can see that bagel is a mass mailing computer worm. Alright, so that tells us a lot actually. So we can look out for internet connections, emails. Yes, and let's move on to details. So on details tab, we can see SHA, SHA-1, SHA-256, hashes, and file type Windows 32 executable, creation time, as well as its aliases and PE sections actually. So you can see virtual size compared to raw size. We can see that it's packed. We can use a tool called PEID to actually look at these sections, but the virus total also shows them as well, and also the imported APIs. You can see there's a lot of important function calls, API function calls. Alright, but we are going to use dependency walker to further analyze the imports. Well, metadata, and for community tab, it's actually interesting because this is where other researchers can upload their own analysis of the malware. So this is the SHA-1, should be SHA-1, yeah, no, SHA-256 hash of the malware. So it actually runs drop executable, injects drop images, suspicious delay, so we can get an idea of what other researchers have found. So we can use that information to actually look out for important artifacts of our malware. Now going back to the VM, we're just going to extract this. Actually, I've already extracted the malware and also unpacked, but I'm going to show you how I unpacked it using FUU. So what you have to do when you unpack the malware, it's actually just a file. So the password is infected. It's just a file, so you have to rename it as .exe so it can become an executable and we can run it. We're going to do static analysis in Windows 8 because most of the tools that we're going to be using for static analysis is in our Windows 8 VM. So just drag the worm. Oh no, you don't drag. Browse for the worm and then unpack it using UPX, but we need to actually look at the malware first before we can unpack, because we need to know what unpacker the worm author has used. So we can use PEID and RDG, packer detector. So in PEID, you just drag and drop. You can actually see nothing found in the compiler, but we can see that EP section is UPX, so we already know that it's packed by UPX. But if you want to confirm, you can check the entropy 7.82, means it's packed very close to 8. And look at EP sections if the virtual size is bigger than the raw size. As you can see, yep, it's bigger than the raw size. Since we have nothing found, we can also check RDG packer detector, set to MB, and open. Look for the worm, packed worm, detect, and we can see UPX. So going back to FUU, you can choose the plugin UPX Unpacker and then just unpack it, and they will ask you to rename that. But since I've already unpacked, just name it unpack.exe. Alright. So we're going to use this for our static analysis, and make sure you have a snapshot of this so that we can go back and in case of system corruption, or if we accidentally open the file, run the malware, I mean. Bakit ngayon ka lang dumating? Now that we have unpacked the malware, we can go ahead and take the fingerprint of this malware using WinMD5. You can just drag and drop. So you can see this is the hash E115ED. That's all we need to know. So if we find another dropped executable, we can run it through WinMD5 and see if it's a copy of itself or a totally different drop malware, malicious executable. Now moving forward, we can now check administrative information using PEView. Open, and as you can see, MZ indicates that it is a PE executable. We can go to headers and look at the file header, and we can actually see the time date stamp of this. It actually corroborates to the virus total creation time that we got. If we go into details, it's also 2006 February 3. Yeah. You can also look at size of each headers, EP sections, PX, not imports. We can also see directory table, but we're going to use a different tool to look at the imported DLLs, imported libraries. So for imported libraries, we're going to use dependency walker and just drag and drop the unpacked malware. Okay, so we're just going to focus on the imported functions. Let's collapse everything first. Alright, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 total imported libraries. So let's first look at the kernel 32. We can actually see that they have release mutex, open process 32 first, WinExec, create tool help 32 snapshot, create thread, create mutex, process 32. A lot of interesting API function calls. This would mean that the malware creates a mutex object to avoid simultaneous access to a resource. So it checks if it has already infected the computer, and it wouldn't run if it already has. Some of these, process 32, open process, we can actually see that it creates a additional process. So we can look out for that. It could create additional process. Reduce command line, create that process. Create tool helps 32 snapshot. Could be that. And yeah. So for user 32.dll, we can actually see that not a lot of API function calls for this library. but we will look at it further when the malware is run, because it does have a lot of things that it imports to. You have get last error, token membership, many other DLLs. Moving on to W3 sock32.dll, we can actually see that it imports, it calls socket, send, bind, accept, listen. So we can conclude that it can permit an incoming connection attempt on a socket, which could possibly be used to create a backdoor. Olio32, not much. This one is just manipulation of strings. Wininet, we can actually see that internet open URL. So now we can see that the worm connects to the internet. Let's look at the strings for that malware to see which domain does it connect to. So at vapi32.dll, registry key manipulation, we can see that it can create key and delete key, that and set value. So you create and then set a value for that created key. So we will look out for registry changes as well, probably for automatic startup for this malware. URLmon, this is URL download to file, so we can expect that malware also connects to URL and downloads probably additional a copy of itself, maybe. We don't know why does the worm do that, but we will see. Okay, for shell32, it contains shell execute a API function. This function can be used to send malicious commands to the shell window. And for finally GDI, not much. It just shows that this malware could have a graphic user interface, GUI. So that's it for dependency. Let's move on to bintex to look at the strings for this malware. Okay, we can just drag and drop that. Alright, now that we have opened up the malware in bintex, we can see a lot of interesting strings. A local loopback address is here. We do not know. Software disappearing. This string could be used for registry, to create a registry key. So software disappearing, DSPL objects, and then windspl.exe. So they are next to each other, so they might be to combine these strings to create a registry key. We also have this bagel author, 29 April 4, Germany. So it is indeed a bagel. This might not be where it is created, but this malware might not be created by an author in Germany, but it is a good information. And then we have this IP address, so that now we actually know that this is the domain that is trying to connect to, using that URL to download file API function. Following that, we have image, BMP, GIF, JPEG, we can also see that they're close to each other, and from the virus total community, they've said dropped images. The researcher said it injects dropped images, so we can see that this image .gif, .bmp, and .jpeg could be downloaded from this site. Alright. Next, we have software Microsoft Windows current version run. This is used to start up, automatic startup for the malware. So now we can expect that this malware wants to run automatically during startup. And we have Internet Explorer next to each other, so this suggests that there will be an attempt for execution of the web browser as well. Now moving on, you can see hello.net.com.org. There's %s. So this is a format, and it's an automated. Let's see. It's actually an automated creation of mail from and recipient. Then we have this emails that ends with Hotmail, Microsoft. This could be used to send the emails to, or probably avoid the emails to send ending with at Microsoft or at Hotmail. Now we can see a lot of .exe names for this, and that so for dynamic analysis we will look at these exe dropped files. This could be dropped as this could be dropped by the malware, and we should look at the fingerprint of this, if it's just a copy of itself or totally different executable. But we can see that it's kv-serials.txt.exe, Kaspersky antivirus. It is highly probable that it is just a copy of the virus, the worm, just with different names. Maybe it could be an alias to create a fake email. A social engineering. So these names could be used to create the email to social engineer people into downloading probably antivirus or porn or new Opera browser, different apps. And then we have date, time is here. Now we can see interesting, this is the content of the email that the malware is trying to create. So these strings are all emphasizing on the attachment, which suggests that this email message is diverting the attention of the victims to it. Therefore, the victims might be curious about the attachment and end up opening it. As a result, the malware is able to infect the victim system. Now let's move on to... Right, this is just the API functions. More IP addresses, domain names. Here's an interesting string: system current control, shared access, firewall policy. So we can expect that the malware is trying to add itself to the authorized application to bypass firewall rules. 1000 and SMTP bugler. This could be a potential mutex names for us. We can see that this is SMTP, and hence we can deduce that this malware uses its own SMTP engine to propagate through email. Next up, more domain names. So it just connects to a lot of domains, web servers. Now we have regis32.exe. There is a slash to that, so this might be used to create a key for this regis32.exe. So this could be a potential dropped executable as well. Now we can see interesting strings, sedebug privileges, adjust token privileges. This could mean that if this malware could try to escalate its privileges so that it can automatically run out as an administrator without permissions. Now we can see drop Skynet, system mutex, interesting strings about Skynet. I think it's trying to compete with resources with the Skynet if the system is also infected by Skynet. So it's trying. Moving on, we now can see my AV, Tiny AV, antivirus, Panda AV engine, Norton antivirus AV. We can see common antiviruses names, and we can deduce that this malware could try to retaliate antiviruses. We suspect that it tries to disable malware antiviruses from running automatically during startup, so it'll be hard for the computer itself to protect from this malware using the key current version run. Yes, it could delete that value with the names for these antiviruses to prevent antiviruses from running on startup, and the malware could just run straight away without detection. So I guess that's that for strings. Now we can move on to PE Studio. This actually helps us to spot suspicious artifacts such as API function calls and strings as well. Look at suspicious artifacts such as UPX0. It actually looks at the EP sections as well, and it detects as software packing to for defense evasion. Yes. And SE-debug privilege, man in the browser. So SE-debug privilege could actually be exploited to inject software into a browser that allows them to inherit cookies, HTTP sessions, and SSL client certificates of a user, and use the browser as a way to pivot into an authenticated intranet. So browser pivoting requires SE-debug privilege, API call, and a high integrity process to execute. More on that, system time discovery with get tick count. It's not really malicious. And here, modify registry, we have set value, delete key, virtualization, sandbox evasion, sleep, execution through API, create process, defense evasion again, execution through API, win exec. So we have discovered that sleep can actually be a virtualization evasion technique, and is categorized as a defense evasion. Now we can have process discovery as well. And yeah, that's it. That concludes our static analysis. Let's move on to the summary. So, to summarize what we have found during our basic static analysis, we have found that it is a worm. It's UPX packed, and the creation time is February 3, 2006. And it creates a process, windsvl.exe and regis32.exe, and drops a ton of executable files with different names. It also creates mutexes, prevents Skynet, worm Skynet variants, as well as it connects to the internet to download images or a copy of itself. Possibly create a backdoor, change registry keys, automatic runs for this malware, or disabling antiviruses called antivirus retaliation, and uses its own SMTP engine to email itself.